So, hello everyone again. This is lecture number 10 part 1 of semiconductor electronics materials, devices and simple circuits. In the previous lecture we discussed about transistor as a switch, a little bit more discussion is required I think, and then it will be over. Then we will move on to the next application, that is transistor as an amplifier and transistor as an oscillator. So, let us start our discussion directly. I am Sameer Lavankar. Let us begin our discussion. So, first of all, course outline for you. We started with the introduction, in which we understood first of all the history of semiconductor devices such as cathode rays, how were it different from the initial present semiconductor devices, what were its size, what was its capability and so on. Then the next concept of classification of metals, conductor and semiconductors, we devised several different aspects in which we can basically designate what material can be called as a conductor, what can be called as a semiconductor, what can be called as an insulator and so on. Next thing was about in this we also understood the band theory of solids. Then next was about intrinsic and extrinsic, two different types of semiconductors were being understood. One was regarding your p type and next was n type. When this p type and n type were being understood, we understood what is p n junction. So, basically the accumulation of both of them, one a p side, one a p type semiconductor, one an n type semiconductor, when joined together leads to the formation of a p n junction. Then we understood semiconductor diodes. Then next was application of junction diode as a rectifier, half wave rectifier, full wave rectifier were being understood there. Then we also understood special purpose p n junction diodes such as Zener diode, then it was a photodiode, then there was a light emitting diode, one which was type of photodiode only, then there was one which was solar cells. So, these all things were understood in the 8th point. Then moving on to junction transistor, which we are currently right now, in which we understood basically first of all what is a transistor, then what are different types of common, we understood 3 different parts of a transistor. Then we also understood what is common emitter, common base, common collector, etc. In this complete outline we are understanding common emitter only, so as to make things conservative and so as to make it concise. Then we also understood in the previous lectures as in how a transistor works, what is forward biasing, what is reverse biasing, etc. has also been explained. In the last lecture we understood about transistor as a switch, the working of a transistor as a switch. Let me revise that once again, and then we can move forward with transistor as an oscillator. And after this is complete, we will move on to the final concept, that is digital electronics and logic gates, and finally a small concept about integrated circuits. So, let us begin our discussion. So, first of all we should first of all know that we are only and only confined to CE configuration. So, let us understand the transistor as a device in which a CE configuration is used. What is CE configuration? CE is basically common emitter. Common emitter. Okay. So, please remember this line very carefully, that when the transistor is used in the cutoff or the saturation state, okay, then it acts as a switch, it does not act as a switch in the active region. Okay. And on the other hand, what about amplifier? Amplifier on the other hand, for using a transistor as an amplifier, it has to operate in the active region. So, just to explain to you what are these 3 regions, as a small revision, we have already understood what is these 3 regions. So, this is basically your cutoff region, this is basically active region, it is generally linear as you can see here, and this is your saturation region. As the name also suggests, saturation as in the amount of change in the value of VO with respect to VI is very less. Fine. So, I think these all things were being completed, I will just revise it again. So, basically we just need to find out what will be the output or basically V naught with the change in Vi. Okay. So, it was being observed that VO changes, as you can see VO changes as Vi increases from 0 onwards, and basically it is being said that for a silicon transistor, as long as Vi is less than 0.6 volts, that is as long as Vi is less than 0.6 volts, the transistor will be in cutoff state. Okay. So, the transistor will be in this state basically, and hence the current IC will be 0. So, if the current IC is 0, it is quite evident that this VCE will be nothing but equal to VCC. Okay. That is only written here, as we also this VCC is nothing but equal to V naught. Okay. So, V naught is equal to VCC. Next thing is what happens when Vi is greater than 0.6 volts, the transistor is in active state. So, this is the active state with some current IC in the output path and the output V naught decreases as the term ICRC increases. Quite evident, as you can see clearly here, as the value of IC will increase, this complete value will decrease. So, that is why, and that is why next thing we should understand or we should remember is, first of all, that the transistor is only and only used in cutoff and saturation state. It is not being used in active state. So, it is being made such that the transistor should only be either in cutoff state or directly in saturated state. Fine. So, moving on, with the increase in Vi, with the increase of Vi, IC increases almost linearly. So, V naught decreases linearly till its value become less than 1 volts. Okay. I think these all things are being explained. So, finally, I just need to make you understand. Okay. So, yes, this is the final line, that the switching circuits are designed in such a way that the transistor does not remain in active state. Okay. So, this was the final line which we need to understand, as in I will just write it again here. So, basically for a switch, and for a transistor, sorry, for an amplifier, active region. So, please remember this, because this is the main characteristic or main usage, how we can implement the same transistor as an switch or the same transistor as an amplifier. Fine. So, that all things being done, let us now start today's topic, that is transistor as an amplifier. So, before starting this transistor as an amplifier, we must first understand what is an amplifier. As the name suggests, amplifying something. Okay. So, let me just explain to you using a signal. So, let us suppose that we have some signal in this form. We have some signal in this form. What are the characteristics of this? So, first of all, we will say that this is the complete time period for one complete cycle. We also know that time is nothing but equal to 1 by f, or we can also say that f is nothing but equal to 1 by t. F is what? F is frequency. Okay. Next thing is this is nothing but the height. This height is nothing but called as amplitude of the cycle or amplitude of the signal. Amplifier is a device which amplifies the signal when it is passed through it. Okay. So, I will just write it here. So, amplifier is a device which increases or amplifies. So, increases is nothing but basically amplifies the amplitude of the input signal. So, this is nothing but which is called as your amplitude. Now, what does a transistor or how does a transistor does amplification is, first thing we should remember is there is a 180 degree out of 180 degree change in phase of the amplitude which is being obtained. What does it mean by 180 degree change in phase? So, let us suppose that we have a signal. We had a small signal like this. Let us suppose this was your input signal. Let us suppose this was your input signal, and let us suppose after this amplifier, after the amplifier, after obtaining it out of amplifier, the output was like this. So, you can clearly see there is an increase in the amplitude, but you can also see that the first sine wave or the first part of the wave was in the positive direction. Here the first part of the wave was in negative direction. This is what is the meaning of 180 degree change in phase of 180 degree, or we can say that the amplitude or the output signal is out of phase with respect to the input signal. Okay. So, this is the first critical thing which we need to remember as we move on. We will try to mathematically calculate also how this value is 180 degree out of phase. So, this was the first concept. Now, let us start understanding what does it mean by, or how we will use transistor as an amplifier. Fine. So, let us start. So, for using the transistor as an amplifier, we will use the active region. Please remember, I also explained you in the previous slide also that transistor will be always be functioning in the active region of the V naught versus Vi curve, of the V naught versus Vi curve. Okay. The slope of the linear part of the curve, this is the slope they are talking about. The slope of the linear part of the curve represents the rate of change of output with the input. It is quite evident, as you can see, this is nothing but equal to delta V naught, and this is nothing but equal to delta Vi, correct. So, it is nothing but rate of change, that is delta rate of change of output upon rate of change of input. So, this is nothing but this linear part what it is telling about. I will try to go slowly. Fine. Next thing is it is negative. It is negative because the output is VCC minus ICRC and not ICRC. So, because of this negative sign being input here, that is why there is a case in which we can find out that the value of the slope being obtained here is negative and it is not positive. So, how this VCC minus ICRC came, it is quite evident, you can see from here also. So, this value being obtained is nothing but equal to VCC minus ICRC. Fine. That is why as input voltage of the CE amplifier, what is CE here? CE is basically common emitter. So, that is why as input voltage of the CE amplifier increases. So, as Vi increases, its output voltage decreases, Why does it decreases? Because as Vi increases, this value of ICRC will increase. As this value of ICRC will increase, the complete value of V naught will decrease. Why? Because there is a negative effect of current on output voltage. Okay. So, that is why as input voltage of the CE amplifier increases, its output voltage decreases and the output is said to be out of phase. As you can see here, it is said to be out of phase with the input. I think it is now clear what is it mean by out of phase with the input. We will try to mathematically calculate it also in the subsequent slides, but for now just understand that what is the meaning of out of phase with the input. Out of phase with the input basically means that if the first part of the sinusoid is in positive direction, then in the output the value or the first part of the sinusoid will be in the negative direction and its amplitude will be much more higher than that of your input signal. Okay. If we consider delta V naught and delta Vi as small changes in the output and the input voltages, then delta V naught by delta Vi is called a small signal voltage gain. Okay. Please remember, this can be asked in small questions, 2 marks questions, that what is small signal voltage gain. I will just write it here also. Small signal voltage gain, which is denoted by A subscript AV. AV is nothing but equal to, please remember, it is delta V output, okay, it is output upon input, it is always output upon input. Okay. Fine. That thing being said, now let us understand next line. So, if the VBB voltage has a fixed value corresponding to the midpoint of the active region, let us suppose this is the midpoint of the active region they are talking about, the circuit will behave as a CE amplifier with voltage gain delta V naught by delta Vi. Quite evident, it is just the definition which is given here. So, voltage gain will be nothing but equal to delta V naught upon delta Vi. So that we can understand what amount of voltage is being added up. Quite evident, if the signal is being having a small amplitude, and it will have a small voltage value, and if it is having a large value, then it will have a large voltage value. So, that is how we can understand that with the increase in the value of AV, the amplitude value will also increase. Fine. Moving on. So, we can express this voltage gain AV in terms of the resistors of the circuits. Let us understand how they are trying to do it, and the current gain of the transistor as follows. So, first of all, what is V output? V output is nothing but VCC minus ICRC. This can be also understood in another pattern. So, basically VCC was the output EMF, and that is nothing but equal to VCE plus ICRC, because the complete will be utilized by two different things. One will be about the transistor and second will be about the resistors. Okay. So, just changing it a little, we finally obtained it is nothing but, so VCE is nothing but your output voltage, correct, because this is the output which is being obtained across this device which we now require, and therefore, this VCE is nothing but V0, which can be written as VCC minus ICRC. Okay. So, that is only being written here. So, that is the first concept. Second concept, before going forward, let me just make you understand what is being happening here, so that we will be more clear as to understanding what is being explained as a transistor which is used as an amplifier. So, this basically means that an input, this is basically an input AC signal. And this is basically your output AC signal. Okay. This is your capacitor. This is also your capacitor. So, I will just mark it the same way. Okay. Next thing, this is your transistor, normal transistor with a common emitter, as you can see. This was your input EMF or input voltage being occurred, and this was your output voltage being occurred, right. So, in this complete Kirchhoff's rule formulation, which was also being understood when we are understanding transistor as a switch also. Now, let me make you understand why is there a capacitor being installed here. Okay. So, if you have understood or revised the concepts of electrical charges and capacitors, which was one of the previous chapter in class 12th only, the main usage of this capacitor is so that the direct current which is coming from this should not pass through this capacitor. The capacitor does not allow the passage of direct current through it. What it will allow? It will only allow alternating current. Hence, the current through this will be passed through here, this will be passed through here, and therefore, the complete summation will be passed through here. And therefore, due to this there will be a change in IB. With the increase or decrease in IB, there will be a change in IC, and due to this change in IC, there will be an effect on this VCC. So, that is how this complete formulation is being occurring here. That thing being said, let me just move forward and make you understand what is being happening. So, I just made this so that you can understand what is being written in the diagram or explained in the diagram and what is the basic use of this capacitor. Fine. So, that thing being said, therefore, what is delta V naught? What is change in the output? Change in output, as VCC will not change, VCC is the constant voltage which is being provided. So, it is 0 minus RC into delta IC. Okay. There will be change in the collector current. Similarly, from this VI also we can also write. So, what is VI? VI is nothing but equal to IBRB plus VBE. So, basically this will lead us to two different things. One will be IBRB and next will be your VBE. VBE basically this voltage, correct. So, this is the same equation which we also used in transistor as a switch also, and therefore, what we can write for a small voltage delta Vi, we can write delta Vi is nothing but equal to RB into delta IB plus delta VBE. As there is no term of delta VBE here, therefore, there will be no term of 0 here, correct. But delta VBE, that is this change in VBE is very small in comparison to delta IBRB in the circuit. Therefore, just moving forward, how can we calculate the value of voltage gain? So, voltage gain we also know it is nothing but delta V naught upon delta Vi. So, I will just write here and then I will close this part of the session. So, delta AV will be nothing but equal to delta V naught upon delta Vi. Delta V naught was being obtained as minus RC delta IC, and Vi will be obtained as nothing but equal to RB delta IB. If you remember the starting concept, starting definitions of transistors, we understood that this delta IC by delta IB is nothing but called as beta AC. Okay. So, just inputting it, doing the input here, we will finally obtain what is this AV is nothing but equal to beta AC into RC by RV. Okay. So, this is the first concept. Let me just introduce as equation number 1. While moving forward, we may use it and then we can finally understand what is the amplitude increase being done by a transistor. Okay. So, let me stop it here only. we will meet again in the next class of this part only. So, thank you so much.